Today we're going to work on a problem from the third Academic Excellence Workshop. So this is problem 1A from worksheet 3. So what's going on in this problem is we've got a block and it's sitting on top of a cage. And there's a weasel and he's pushing down on the block at a certain angle, theta. And so our main job is if the ground between the cage, or if the surface between the ground and the cage is frictionless, we've got to determine, is the block going to slide with respect to the cage and fall off, or is are the two as a system going to accelerate off together? Okay, so the way that we usually go about this is just like any other problem. So we start off with some free body diagrams and some labels and everything else. So I drew a nice picture here. We've got the block sitting on top of the cage with the force and some axes drawn. And then I drew two free body diagrams. So one system was for the block and one was for both the block and the cage. So I could draw one for the cage by itself and that'd be fine, but it turns out that these two are going to be all we need. So on the block, we've got, as we expect, a normal weight, a friction force, which we expect if we want these things to try to stick together, and the force from the weasel. And then on the system of both together, the really nice thing is that we got rid of that friction force, which is great since we know nothing about it. And since it's internal, it's not going to show up on the combined system. So we've just got a few other forces on that. So the way we generally go about approaching one of these problems is we say, all right, what if the block stays together? You know, the two don't slip. You know, what conditions have to be met in order to make that happen? So we're going to assume that it does happen, that they do stick together. Well, if that's the case, then why don't I do this? I'm going to take both as my system, and I'm going to sum my forces in the x direction. Because I know I can take both as my system since they're not sliding with respect to each other under my assumption. So if that's the case, then I sum up my forces in the x direction and use both masses together as my mass for the F equals ma calculation. And then we just solve for the combined acceleration of the system. And so we'll be solving, of course, for this variable right here. So after we know that, we know if it doesn't slip, they're going to go off together at that acceleration. And this block, the top block, is going to have to move at that acceleration, or else it's not going to stay with the other one, right? So after we know the top block's acceleration, we can easily go back and say, all right, let's sum our forces on the block now that we know its acceleration here. If that's the case, our only unknown left is friction, and we'll solve for that. And once we find that friction value, we'll say, okay, that friction value is how much we need to make this thing stick together and accelerate together. And so that's a value that's going to be really important to us. The question is it bigger or smaller than the maximum possible value? So is it possible for it to stick together? Because if it is possible, then of course they're not going to slip if they don't have to. So the way we figure that out is we calculate the max static friction force, which we know is equal to mu sub s times the normal force, the coefficient of static friction times the normal force. And if we do a sum of forces in the y calculation on block 1, we can easily find that the normal force turns out to be the weight of the top force, or the weight of the top block, plus the y component of that incoming force. And if we just plug in a bunch of numbers, I've included the numbers over here. If you want to plug those in, you'll find out that the maximum static friction force is indeed greater than the force that we actually need to keep them together. So we know that it's possible for them to stick together. So this block will not slip. Now, one really important thing that I want to mention that a lot of people get confused is the fact that had you just taken the x component of this force right here and said, is that bigger than the maximum static friction force or not, you would have found out that it was. And so you might have thought, well, this thing will probably slip because it's bigger than the maximum static friction value. But as we know, it's very important to come back and solve for what we actually need, because the acceleration can make tricky things happen in the relative sizes of the forces.